So thank you. I thank all the participants for your attention to the second session. It's time to move ahead to the third and the final session of our Atal Faculty Development Program. I would like to request Dr. K. Kiran Kumar Rao sir, the co-coordinator of this FDP, to kindly take the stage and introduce our final resource person of the day, Dr. Pooja V. Anagolkar.
Good evening all. Thank you for your patience. I am immensely happy to present the profile of Dr. Pooja Garu. Dr. Pooja V. Domalkar is a leading expert in digital manufacturing, robotics, and artificial intelligence. She holds a PhD in machine learning and metal additive manufacturing, along with a Master of Technology degree in CAD/CAM. Currently, she serves as head of the robotics and automation department at Angadi Institute Technology and Management, a position she has held since April 2024. Her notable achievements including establishing the Center of Excellence for Digital Manufacturing and receiving several prestigious awards such as the IRST Prominent Innovative Educators Award on 2023 and the Best Paper Award at AMMA 2023. She has also been recognized for her excellence in additive manufacturing at AM Tech on 2023. Dr. Angolkar has made significant contributions to academic research with multiple publications in renowned journals focusing on additive manufacturing and tribological properties of materials. She actively participates in academic accreditations processes and has secured various research grants through industry partnerships. Beyond her academic work, she serves a number of the board of examiners for mechanical engineering and robotics at Visvesvaraya Technology University and has worked as a team leader for IIT Bombay's E-Yantra Lab Initiative. Notably, she also has a background in sports, having represented Karnataka in women's volleyball at the state level in 2022. Over to you, Madam Dr. Pooja, please.
Thank you for the introduction, sir. Good evening to all the participants. It is my pleasure to welcome you all to this presentation on robotics for AI integrated next generation electronic devices. I have been in this robotics and AI for around more than 5 to 6 years, and in more of automation and computer aided manufacturing or computer aided integration. It has been a decade with me. But since this FDP is related to electronic devices, that is especially semiconductor devices, I'm not an expert in semiconductor devices, so I'll be talking on how robotics and AI have been integrated into your electronic devices. Coming to what is robotics? The design and use of automated machines that perform tasks traditionally carried out by humans. So whatever complex tasks are there, those which the humans cannot do repeatedly with higher efficiency, those can be given to the robots or taught to the robots. Because when we are talking about next generation electronic devices, we see that robotics is having three branches, or you can see three domains. It is having electronic components, it is having computer science for programming, and it is having the mechanical components. So when we have the integration of all these three, only then the robot can work. And mainly when we come to the integration or convergence with these three branches, we see that electronics plays a major role in making the robot move or do the things. And mechanical has its own perspective of balancing, using the type of material for the robot, and the flexibility what the robot should have in a specific task, what material has to be used, and when it can be stable and it can move to and fro. So these all motions and materials manufacturing, this all for the robots comes from the mechanical background. The electronics parts comes with the sensors, actuators, IoT, and other things. Whereas computer science, we can see more of AI, that is computation. Then we can see machine learning. We can see natural language processing, and so many other things that are coming into convergence here. So the importance of integrating AI for precision, efficiency, and scalability. So when we say precision, we see the human workers are being replaced by robots, or due to automation they are being replaced. But that replacement is calling for upgradation of the skill of the humans. For example, when I'm talking about robotics or AI, it is not that within one day we have learned something and we are talking here, right? So we are trying to get the knowledge. We have had some hands-on training. We have upgraded our skills, and then we have come to this level. So similarly, when we say people are being replaced by the machines, it is for the upgradation of skill. It is calling for the upgradation of the skill for the humans. So once the humans try to upgrade their skills from unskilled labor to skilled labor, so I think at least semi-skilled labor to at least supervise the machines, that should not cause any harm to the human welfare. Next, we see impact on the industries like consumers, electronics, automotive, healthcare, and IoT, that is the Internet of Things. So when I say AI, it is the simulation of human intelligence in machines, enabling them to learn, reason, and solve problems. So I'm going to simulate the computer. For example, when I say a machine, I will say a human computer, which is going to be used for the same work what the humans are going to do. So I'm teaching the computer. How am I going to teach the computer? I will be teaching with the help of some algorithms or machine level language. So what is that machine level language? There are so many languages in which, for example, I'm speaking in English. The computer cannot understand English. It understands only binary level language. So it will convert the whatever I'm speaking, the speech, into binary language and execute the program. Or whatever program I give, whatever codes I'm writing, that only those line by line it is going to follow. So why we are combining this robotics and AI for electronics? So firstly, it is going to enhance the precision and efficiency in manufacturing. So when we say we talk about electronics or we talk about mechanical components, it is more about how we are manufacturing them. So when it comes to manufacturing, there the human intervention is required. When human intervention is required, there is precision and accuracy required from the humans, which in the past, if we see some case studies, there were some cases where the errors have occurred in the components. So to remove those, to have a defect-free environment or defect-free product, we are bringing robotics into the automation, and we are replacing humans where repetitive tasks can be done by robots and which do not lead to any defects, because robots or automation machines which are programmed cannot make mistakes. Next, it facilitates the creation of smarter and more adaptable devices. For example, Bluetooth connected devices which can be operated remotely or from a distance. Or if you have any other, Wi-Fi connected devices with the machine and the humans. So this all collaborative work that is happening on the manufacturing floor, that is giving enhanced, ability for the humans and the manufacturers to bring out good quality products. So this combination of robotics and AI in electronics will drive innovation in human machine interfaces and autonomous systems. So human machine interface is nothing but again the cobots, that is collaborative robots where humans and robots are working in collaboration. And we have the autonomous systems, for example, driverless cars, we have drones, those are driverless, or you can say pilotless vehicles. And we have so many devices or moving robots, which are, cleaning robots. So these are all the autonomous vehicles which are we are talking about, the unmanned aerial vehicles, if we say. So these all come into picture when robotics and AI is having integration with electronics. Coming to the objectives, I will be covering role of robotics in electronic device manufacturing, integration of AI for smart manufacturing, applications in next generation devices, and then the challenges and opportunities, and the future trends and research directions. I will be talking one slide on the future research, what people can take up who are attending this FDP, what could be the probable research areas you can get in the takeaways from this. Coming to the role of just a minute. Yeah. Role of robotics in electronic devices. So we see, as I told you, automation. So how is robotics helping in electronic devices? That is, robotics is enabling automation in manufacturing and service delivery, right? It is helping in precision, that is, perform the task with accuracy and reduced errors. Because as I see, the electronic components are very small and compact, minute. They are just like a miniature. So handling those components with utmost care and with lot of, you can say they are fragile. So with that sensitivity, it has to be handled. So that is where robotics is helping us. Adaptability, that is, robotics can be programmed for various tasks, making them versatile for different applications. Now, by different applications, what do I mean? So we have smart home devices. We have robotic vacuum cleaners. I see most of the people using, adapting to robotic vacuum cleaners nowadays. And then we have AI powered assistants, right? We have voice assistant. We have so many devices which are answering our calls. We have so many devices which are listening to us. For example, if I say home automation, so home automation is another, area where you are entering, an apartment and your face is, seen in the camera. Only then you are recognized as a visitor to a particular apartment. They allow you inside. So after you go inside, then what was the time of the entry? What was the time of the exit of the person? So everything has been recorded. So this is where the automation, comes into place for electronics. Next, we have healthcare robotics. That is presently what is practiced. That is about the surgical robots. We see so many orthopedic robotic surgeries. We see so many types of surgeries that are happening. We see, doctors are operating like virtual operations happening, surgical treatments happening, where the doctors are somewhere else and the robot is following those instructions. So these are all the examples where the AI has been integrated with robotics. So what do you mean by the next generation electronic devices? Now, for simple mechanized tools to programmable robots, for example, when we say industrial robotics for electronic manufacturing, we have seen the electronic chips or the breadboards that were manufactured by simple what do you say you know kind of manufacturing where only the part was cut out from the plastic part was cut out, right, and made into a particular shape. But that has gone into something where we have designed and fabricated a machine which gives us directly the pebbles which are of that particular material, plastic, are going to be melted to a particular temperature. Then there is there is a replica of the breadboard that is there in the sample. So that is going to fill it. It is going to be cured in the sense it is going to be burnt, and it is burnt, not exactly burnt, little lower to higher temperatures, and then it is going to be brought out. So that is the beauty where we have gone from conventional manufacturing to present manufacturing, where we are using even 3D printed breadboards. So 3D printing hardly it just takes minutes. You're just giving the 3D model to the computer CAD model. It is just converting it into a STL file. It is printing it and it is giving you. So these are all the automation, or you can say enhancements, or advances in manufacturing that have taken place. And the AI role in advancing robotics, that is perception, decision making, and learning. So devices characterized by advanced technologies that enhance user interaction and functionality. Examples include, as I said, smart home devices, autonomous vehicles, drones, and wearable technology. So we have so many wearable devices at present. Many of us are using the digital watches, which shows you your BP. It monitors your BP, your heart rate, and so many other things, your walking steps. So many things are inbuilt in that wearable device, that it takes everything into consideration, and that is the technology that has come up. So there we are seeing the integration of AI with the electronics. So focus on connectivity, intelligence, and user-centric design. So when we say wearable technology, it cannot be very big, right? It has to be comfortable for the humans to be in the hand, or to wear in the hand or wrist, whatever you can say. So when we say user-centric design, there is a survey that will be conducted by the company to understand what are the needs of the people. From the market survey, the design and the automation and manufacturing, these all processes start, and it ends with the delivery of the product. So this connectivity and intelligence is nothing but about your Wi-Fi, Bluetooth, that is connecting to the device. So that is how the user-centric design comes into picture. So miniaturization of robotics for portable devices and integration of IoT with robotics for interconnected systems. So this IoT, it is a big, ocean where there are so many applications that come up with IoT, Internet of Things. So we can connect from one machine to the other using our network area, that is LAN, and that allows us to understand which machine is working on which components and for how much time. So when AI is integrated with this robotics or robotic machines, what happens? So here we see how AI is enhancing the robotics, that is machine learning. Robotics can learn from data and improve over time. So the robots, whatever data you feed it, maybe the data is in lakhs of data, or you run the data, you use the data, you run the trials and see. It is going to learn from all those trials. That is how the machine learning is working. Now, when we say it is computer vision, it is nothing but enables the robot to interpret visual data for better interaction with that environment. For example, if I have a camera fitted over the robot, so it knows and it will identify the object, the shape of the object, and it will move to the next. So, for example, sorting machines are there. So there is a box of chocolates which are in different shapes. It has to go into packing. So when you are going into packing, the robot is checking the shape of the chocolate that it has picked. Then it is going to move the box in the direction where the that particular chocolate, whether it is square or circle, it has to be placed there in that particular direction only, or in that particular place where the place is made for the mold is made for that particular shape. So that is how there are many videos in LinkedIn you can find on this, that is shape sorting machines, or robots which are sorting the shapes in different domains. Not only the chocolate packaging, you can find it in manufacturing also. Another important thing that comes up in AI is your natural language processing. This is the most important part of AI, which allows the robot to understand and respond to the human language, enhancing user experience. Let me tell you that this natural language processing is nothing but the English language that we are talking, but it is little enhanced. And for the machine, or the AI to understand or integrate into a machine, there are protocols which have to be followed, that these particular sentences have to be written in this way. What are the parts of the sentences and how they have to be written? So this natural language processing is, bigger. It takes up the bigger part of this AI in when we are integrating it with robotics or electronics. So when we talk about the subjects that come into picture in AI, that is for robotics, this is the important one, that is natural language processing. We have machine learning, computer vision, we have graphics related, we have electronics, analog and digital electronics, we have microcontrollers, we have basic communication systems, we have linear integrated circuits. Like that, we have the main electronic subjects which we teach to our students so that they can integrate their knowledge, because whenever we have the students coming from different domains to into different branches of engineering, they do not have any basic knowledge. For example, in robotics branch, we have students studying who have completed diploma in computer science. They are students who have completed diploma in electronics and have come for engineering. So they do not have any background for mechanical subjects. Neither do our diploma in mechanical students have the background of electronics or computer science subjects. So when framing the curriculum, these all things are taken care, that no students should face any problem in when they are integrating into one particular branch. So that is why I wanted to specify here why this AI integration in robotics has these subjects or these key parameters. Now, what are the key technologies that are available? Now, when we say key technologies, we know that electronic students, they know about sensors, they know about actuators, but they might not know about cloud computing. They might not know about IoT, or some XYZ branch students might not know some permutation combinations. So when we say sensors, it is going to collect the data for real-time processing and decision making, and actuators facilitate movement and operation of robotic systems. So this movement of robotic system actuators, there are different types of actuators, single acting, double acting actuators. We have so many, drive systems. We have electronic drive system, pneumatic drive system, hydraulic drive system. So these all have to be understood for when we are trying to integrate robotics into electronics. Next, when we say cloud computing, it provides necessary computational power and storage for AI applications in robotics. So, computational power and storage. So, when we are talking about so many things integrating, there is storage required, right? So, when you are going to provide a cloud for it, only then the things are going to work. You cannot integrate everything into a motherboard and put it into a robotics or electronics component. It has to be in the cloud, and the robot or the electronic component has to take the data from the cloud and start processing. That is how it should be. Then the IoT, that is connects devices, enabling data exchange for smarter functionalities. Every time we cannot have an app for every task. We cannot download a app and put the data or process it, right? So for that, this Internet of Things helps us. That is, it is connecting the devices and enables the exchange, data exchange from one place to another faster, so that the functions happen faster. Now, when we see, we talk about advanced sensors, that is LiDAR, ultrasonic, infrared for environmental awareness. Especially these are used in the drones, that is the unmanned aerial vehicles. Then the precision actuators for delicate electronic assembly tasks, edge computing and cloud integration. When we say cloud computing, it goes into edge computing and cloud integration. Now, the role of edge devices in real-time data processing is also important, and cloud platforms for collaborative AI and robotics systems also have to be included. So, when we talk about all this, there is a small gap that is left regarding the materials innovation. As I told you earlier, only from casting to 3D printing, what was happening, the cost, initial cost is high. I agree to that, because the 3D printing machine will give you the output within minutes, but the casting cannot happen like that. It will take some 1 or 2 days, maybe more than 24 hours. So that is how flexible electronics for adaptive devices, where we have, for now, example, if I take soft robotics or SWAM. SWAM robotics are nothing, robots are nothing but the robots which are designed, the outer part of the body of the robot is like any insect or animal that you give it, smaller insects. Okay, I'm talking about. So those smaller insects count to like being like spider or a snail or a earthworm. So when you talk about all these, type of honeybees or anything, you should understand that the body of the robot has to be flexible. So when we say flexible, what material has to be used for the outer body is important. So flexible electronics for adaptive devices means we have to understand for which electronics, which material is suitable and which can be used, which can tolerate that, temperature or pressure or whatever, outer boundary conditions are coming to it. Next, advanced composites for lightweight, durable robotic components. So this is altogether a big topic actually. Advanced composites nowadays, most of the 95% of the research that is happening in composites, that is materials, is happening on composites. So when we talk about lightweight, we see what should be the end product, that is where it is going to be used. So if it is going to be used in aerospace components or very high precision components, its surface finish has to be excellent. So when we talk about surface finish and lightweight, all this, then we should see which are the components or the materials which can be combined to make a composite for lightweight and durable components. Next, coming to the case studies about the successful AI and robotics integration. I told you already, robotic surgery is in place in India already in bigger hospitals and metro cities, and enhanced precision and reduced recovery times. It is taking very less time to recover. That is why patients are ready to pay, extra amount for the robotic surgery, because the recovery is, faster than when, it is done by the doctors themselves. And autonomous delivery drones, efficient packaging delivery using AI for navigation and decision making. This has not yet come to India. It is there in the Europe countries and US, where the medicine delivery is happening, food delivery is happening through the drones. So again, where when we say autonomous delivery through drones, we have electronic components in it for navigation. We have the identification of the location, identification of the person who is taking the delivery. So these all things come into picture. Then we have AI powered robot assistants in homes and offices, like devices like your Amazon Alexa and Google Home utilize AI to control smart devices and respond to the voice commands. But there is a darker side of it, that these devices collect the data from your side. For example, you keep the device on and you're speaking about, say, shoes. Okay, and you open your phone after 10 minutes, whenever you are browsing through Facebook or some other device, you see ads coming up regarding shoes, right? So this is the darker side of the things that we need to observe. You just try this, what I told, and you just see whether it is working for you, because the voice commands, what you keep it on, those are catching the words which are already there in the database, and then they give you the ads related to the same thing. There are AI related prosthetics, robotic prosthetics. You must have seen a recent Paralympic runner. He had a robotic, limb. Both the limbs were robotic, and he didn't have his own limbs. Both the limbs, he was able to run with that AI powered or AI assisted robotic prosthetics. There are AI powered, or you can say feeding assistive devices for Alzheimer's disease. There are so many devices that have been developed and patented for, feeding devices for older people who cannot eat by themselves. There are people, devices which have been patented or, put into use where they are helping the elders to, interact with them, play with them, or, just sit with them and give them company. So these are the things where the case studies are successful. There are also micro robots for targeted drug delivery and diagnostics. For example, when I say micro robots, it is maybe for the organ transfer from one place to another. Where nowadays we see the road transport and even airplane transport is there, but it is taking time. So these micro robots are being used for drug delivery and diagnostics also. Coming to the automotive industry, the autonomous vehicles, that is AI driven perception is there, and navigation system, as we spoke about the drones, and robotics in assembly of EV batteries and components. So robotic assembly, if you see the video of Tesla company, which is there in the YouTube, you will be mesmerized because you see the everything, the whole floor is automated, and the automation or whatever the car manufacturing to the assembly of the car to spray painting, whatever is happening, it is going through the robot only. The pick and place also, it is happening through the robot only. So you can just go back after this session and go back and see that video of Tesla in YouTube. It is a beautiful video. I always show it to my students for showing them to what level the electronics industry and robotics industry have picked up to go and manufacture cars. So that is where the AI driven EV batteries and components also are being done through robotics in assembly. And AI driven robotic arms for precision manufacturing and electronics, and predictive maintenance using AI for robotics. Now predictive maintenance means we are trying to reduce the number of defects. We are trying to have a good maintenance and defect free product and environment. So that is how AI is helping us. Or for example, when I say defect preventive predictive maintenance, it means that when I am doing quality inspection, instead of out of 100, earlier we used to only check a batch, that is only 10 products. If they are defect free, the whole batch was understood to be defect free. But now it is not like that. With AI and your robot vision and cameras, image processing, each and every product can be scanned, and it can be we can understand whether it is defect free or it is having any defects. So the benefits of this robotics and AI in electronic devices, we can see like increased efficiency, that is automation leads to faster production and service delivery, improved user experience, personalized interactions through AI, enhanced usability. For example, if the process of automation is going on and if I find anything is wrong, I can stop the automation at that point through AI. Means I can change the program and I can give the directions for the machine to do the work in different directions or whatever changes I want to do. So that is how it is flexible and it has improved user experience. Now, cost reduction. So, long-term savings from reduced labor cost and increased productivity. So, here it means that the initial investment, see, they are not talking about initial investment here because initial investment is very high. But when we talk about the long-term savings, we can see very high productivity coming out of this automation through AI and robotics. Next, we have enhanced safety. Robots can perform dangerous tasks, minimizing human risks. So, I'll give the example of cleaning of the nuclear power plant, the vessel where we have the nuclear reactor. So, there, when humans are cleaning, they may be exposed to those, harmful chemicals, right? So, in those places, the robots can be used, or cleaning of furnaces, or any refractory lining is there, in those places the robots can be used. Or if we have any underwater devices, we have so many underwater welding is there. Anything that is harmful for the humans, wherever it is harmful for the humans, that can be replaced by robots for the safety of the humans. Now, what are the challenges? So when we say challenges, it comes with a lot of limitations. Now, there are some barriers to this adoption. So integration is complex. Okay. So combining robotics with AI in constrained electronic devices. So we cannot have big electronic devices and say and put it into a robot and say we will integrate it with AI. That is not possible. So we have to see how this integration can happen with constrained electronic devices, means smaller electronic devices or compact devices which can be put into a robot and AI can be integrated. Energy efficiency is there, ensuring AI-powered robots operate efficiently on limited power. See, when we say, integration of robotics, AI, and electronics, we cannot have how much ever power we want and put it into the system, right? We have to be economical when we are using power. So there comes the idea of energy efficiency. So AI-powered robots, we have to work on the optimization of AI powered robots that operate efficiently. Next is the challenges about the data security that comes as a cyber security to you. So data security is protecting sensitive information possessed by smart devices. So whatever smart devices are there with us, we are not secure at present because everything can be seen or opened at any point of time by anyone. So nothing is secure actually. Okay, whatever phones we are having, how much ever you put it, you secure password, but it is the data is stored somewhere in the cloud, right? So that is one part of the coin. The other face of the coin is that it is secure, but to some extent, okay, encrypted, but to some extent. So if the somebody has to, some cybersecurity officer is concerned about somebody's safety, he can open anything and check it. So that is how it works. So data security is kind of important when we talk about these smart devices. Now, high initial cost, as I told you, investment in technology can be prohibitive for some businesses because they are not able to heavily invest in such automation. Technical complexity is there because integration requires skilled personnel and knowledge. So at the starting of the presentation, I told you that where automation is happening, upskilling also has to happen. So again, the when there is technical complexity, again the laborers or the people have to upgrade themselves with the new technologies. Only then there will be growth. Again, the data privacy concern, increased data collection raises issues regarding user privacy and job displacement. Automation may lead to job losses in certain sectors. Of course, it leads, but again, we are not eliminating labor to all, to make it zero, right? We are using the labor for supervision. We are allowing them to program the robot. We are allowing them to fix the electronics component for the to check the safety, to check the whether it is working fine or not. So all this has to be done by the humans. There cannot be 100% displacement of jobs, right? So equally, when I'm talking about challenges, I will talk about opportunities. So what is happening in the opportunities? We are getting chance to collaborate or talk or interact with the robot. So that is called as the human robot collaboration. So when we say about human robot collaboration, again we need to understand the humans need to understand the working of the robot. To understand the working of the robot, they should know the working of the sensors, actuators, the cloud computing, the IoT. They need to know about all the electronic components, how they work, how the relays work, how the gates are working, what is happening at the output, what is the input, what is the type of system that is used. which microprocessor has been used, everything the worker or the human has to know. Next opportunity is creating adaptive self-healing electronics. So creating adaptive means the electronic device has to adapt to the particular environment or to the particular task that is given to it. So that is nothing but creating adaptive and self-healing electronic devices. There are so many self-healing electronic devices that have come up. So some may have read in the news about self-healing, skin, right? There is some kind of sensor which is put on the skin, and it acts as a band-aid. And there are self-healing cracks, not about the human body cracks. I'm talking about the walls. So that is the one kind of gel, electronic gel, that is put into the cracks, where it closes the that part of the crack which is occurred on the wall. So these are few examples where opportunities are being created. Now, enhancing sustainability through efficient manufacturing and recycling. So, opportunity is coming. There is so much e-waste that is there due to increased electronics use. So, that has to be made into efficient manufacturing, so that whenever it has to be disposed, it gets into compost into the soil, like that, or some recycling initiatives have to be taken. So, what are the future trends or future directions when we look ahead? So, that is collaborative robots designed to work alongside humans, enhancing productivity. So, there is one human and one robot in a cubicle where they are working. Whatever the human is telling the robot, it has to follow those instructions. Now, when we say collaborative robots, the robots have the three laws, Asimov three laws. So those, it has to follow those three laws. It is designed in such a way that it is going to follow those three laws definitely. Now, what are those three laws? The first law is it should obey the instructions given by the humans. Second law says it should obey the instructions, but it should not harm the human. If there is any instruction to harm the opposite person or opposite, machine standing in the opposite direction, it should not do that. Third one is that it should not destruct itself. For example, if I have a robot and I'm giving it a data or algorithm or a program to destruct itself, it should not be doing that. So these are the three laws of robots that are being framed in long back, and which the robots have to follow, or the person who is designing the robot or building the robot has to follow. So that is how the robots work. Next, AI powered predictive maintenance, reducing downtime in manufacturing and service industries. Fully autonomous robots designing and manufacturing next generation devices. Collaborative AI driven robot swarms for large scale assembly. So I spoke about swarm robots, right? Regarding the swarm of the robot. Increased personalization. AI will now drive more tailored experiences across different devices. Now we are seeing so many, things being coming up. Say it is Chat GPT. So many things for PPT, for your designing your cards, and so many canvas. So many things are coming up in the digital industry. But the key to all this is to use it for the betterment of the society or for your upskilling. So when we are doing that, we should be focused on using it for the timing in the sense for a time frame. We need not sit 24 hours in front of it and go on exploring. Only what we require, we can take it out from the data, and we can use it. Right. Next, advancements in autonomous technology, enhanced capabilities in driving, self-driving cars and drones. So already there is a movie in some platform, if you have seen. It is about the how the accident happens by the self-driving or autonomous car, and how the person is revived, or how he is kept alive. It is more like a cloning, or how his senses or his cells have been revived and kept and made him alive. So that is the future. They have shown how AI is going to come up in future. You have to pay for every minute or every time or whatever you are eating. Also, you are being going to pay with the card. So that is how the top up of the card happens. So that movie is a beautiful movie which portrays how AI is going to develop in future. How you are going to bring people back into like a virtual people, not with the body, but virtually they'll be there with you. Next, I would like to speak about AI integrated robotics for space and defense applications. So we have seen there are so many robots that we have sent to space. We have seen AI integrated robots means with the camera, which have been, they have brought the information from the space. They have been sent into space for satellite, correction and so many things. Then deployment of robots for electronic systems in extreme environments where humans cannot enter. There we can employ the robots. AI powered robotics for real time threat detection and response. So we can have this as a key feature for the next coming generation where we have real time threat detection and response. The response is done by the team of robots. They help in firefighting or they help in disaster response or in people who are drowning in the water. There are so many things or areas in which this can be done. There is one more future trend that I would like to talk. It is about the bio-inspired robots. That is integration of AI to mimic biological processes in electronics devices and applications in medical implants and soft robotics. So medical implants have already taken over, I think more than 10 to 15 years. It has been that medical implants have been, extensively used. Titanium is being used, aluminum is being used, and so many components which are there, medical implants, and you can say the batteries or, medical, brain batteries, whatever we are implanting, those have been used. So this all counts about to the soft robotics where the electronics and the materials work together. So the same thing, anticipating the next wave for innovation, that is emerging technologies, technological advancements such as quantum computing, advanced machine learning algorithms, collaborative robots will fundamentally reshape semiconductor manufacturing operations. Next is predictions for the industry, that is forecasts predict significant growth in adoption of AI and robotics within semiconductor manufacturing, promising faster innovation cycles and enhances competitive advantages. Next is the research directions. I have a different slide for it, but I'll just read this. Ongoing research aims at developing more sophisticated AI models and robotic systems, focusing on their ability to respond to dynamic manufacturing environments and enhance human robot collaboration. So now the collaboration between the robotics and AI companies, how it should happen. So there has to be partnerships, there have to be innovation ecosystem, and there has to be shared resources. Only then the collaboration can happen. So when we talk about partnerships, usually we talk about academia, industry academia relationships, and we talk about the memoranda of understanding and so many internships. We talk about jobs with the industries and so on. So this partnership can help robotics and AI companies foster knowledge sharing through students, accelerate innovation, and broaden the scope of technological advancement in semiconductor manufacturing. Next, the innovation ecosystem. So, whatever research is happening at your institution, if you can share with the companies, if you can collaborate with them and then share or take a problem statement from them and solve it at your institution and give it back to them, that will be a great innovation ecosystem that you create between the two people. The formation of innovation eco startup that connects startups tech giants and academic institutions can drive the development of breakthrough technologies with collective insights and resources. Next, we can have shared resources that can elevate development costs while enhancing access to advanced technologies, ensuring more rapid advancements of AI and robotic solutions. So, shared sources means your institution has some sources, or your incubation center or digital manufacturing center, and the company or the MNC wants to use that for their manufacturing. You can lend it to them for some time, and that is how the shared resources are going to be helping in collaboration between robotics and AI companies. There are some case studies that I would like to discuss. So we have AI integrated robotic arm for PCB assembly. So this robotic arm is going to be AI integrated through machine learning, and it is going to help in your printed circuit board assembly. So this is one case study. Second is how companies like ABB and KUKA are transforming PCB manufacturing. Now ABB and KUKA are big robotic companies which manufacture PCB. So these companies are designing the robots for this PCB manufacturing. Healthcare innovation, we have Da Vinci surgical system, that is AI and robotics in minimally invasive surgery. As I told you, people are already looking into robotic surgeries. So why they are looking into robotic surgery is because it is minimally invasive. That is not bigger cut, no bigger cut on the body. There is only a small cut, not even half-inch cut, and the surgery is done. And the recovery time is also very less. Next, we have autonomous drones, the role of AI-powered robotics in delivering goods and performing surveillance. Now, surveillance is an important part in military application. So, when we talk about military application, surveillance becomes a very big, help to them. So, through electronics and robotics, if we power it with AI, the drones or the unmanned aerial vehicles, it is going to be very useful for the surveillance. So when we talk about impacts on industries and societies, there is healthcare, that is helping or improved patient care through robotic surgeries and rehabilitation. I spoke to you about the Alzheimer's disease. That is, rehabilitation is nothing but you have assistive devices, you have robots speaking to older people, or you have robots, electronic devices which are helping in monitoring their health. So these are all the ways in which the robotics is going to impact, or electronics is going to impact the society. Then manufacturing, that is enhanced production capabilities and quality control. So as I told you, quality control means quality and testing. When we are testing the components, we can use machine vision or we can use robot vision, and we can sort the things, and this will lead to a defect free product. Any product, if you are manufacturing thousands of products also, there will be not one defect in any product if we are going for AI powered or electronic devices. Next, transportation, safer and more efficient logistics and public transport system. Everyday life, revolutionizing how consumers interact with the technology and access services. So everyday life, see, these all technologies are finally nothing but the last point to make it easier, giving good services to the humans. So whatever technologies are being developed through AI or robotics or electronics or computer science, these are all to make the life of the humans easier, which should not be overused and which should not be exploited. Now, what are the ethical considerations? I do understand that the previous speaker, Dr. Deepthi, has covered more of ethical considerations, but I will give a quick, 4-point ethical considerations on what it should be. The accountability. So, who is responsible when AI is making decisions? So, we are talking so much about AI, AI, AI. What if it starts taking its own decisions? What if the robot does not follow your instructions and takes its own decisions and starts manufacturing the things how it wants? So who is going to be responsible for that? The amendments should be made. Some write-up should be made about the accountability. Next, bias in AI. That is importance of ensuring fairness and transparency in algorithms. That is what I told you when it comes to changing of the algorithms. So, what is actually AI doing? It is, for example, if I'm asking it to write a program, it will write and give me one set of instructions. But if somebody else is asking the same program, it will give a different set of instructions, right? So this bias by AI, so which one to use, whether the algorithm given to me or to the next person. So that is how the things or discrepancy is going to come. The job displacement, addressing the social implications of automation. So, as I told you, upskilling. Not everyone is ready to learn, and especially the unskilled laborers, they are not in a condition. They may not be in a financial situation to upskill themselves, or they may not have that much time or energy into. They may be older class of the society who will not be able to adapt to new terms or new learnings. So these all are the social implications that we need to look at. Next, again, the privacy, that is the cyber security, safeguarding personal data in interconnected world. So whenever we are sharing anything, we don't know who is who are taking it, and they can post anything. So this privacy concern also makes a lot of impact when we talk about the robotics and when we talk about AI especially. And that has to be taken care when AI is going to be integrated with robotics or electronic devices. Now, what are the effective strategies for implementation when we talk about all this? So, investment in R&D encourage innovation through research and development. Unless we do research, there are no good products coming out. There are no patents coming out. You cannot ask your students to directly jump into some innovative projects, right? So that has again to come through your R&D, that is through research and development. Again, your literature survey comes into place, your methodology comes into place. So these are the basic things what we see when we try to talk about innovation. Innovation doesn't happen in a day. So its backbone is your research and development. So you cannot have just a patent just like that. Patent is again, the backbone is again your research paper or your research that you did to get that product out. Next is upskilling the workforce, provide training for the employees to adapt to the new technologies. Right. So when we are asked to teach new subjects or new branches, we should be given some training. So likewise, when the robotics branch was introduced into VTU, we were given training through online mode by VTU, and to all the teachers who are going to teach the subjects. So what are the basic subjects and basic needs required? The prerequisites. These all were considered, and the training was given to us. Partnerships, collaboration with the technical companies for better integration solutions. So as I told you in the previous slides, the partnership should be there. There should be innovation that is happening, and there should be shared resources that is happening. So these all things come into consideration when we think about strategies for implementation. Then user-centric design focus on creating user-friendly devices that enhance user experience. So that is how the strategies come for implementation. Now, coming to the research part of the topics, when we talk about these three domains, that is robotics, AI, and electronics, you can look into autonomous robot systems for semiconductor wafer fabrication, right? So this wafer fabrication also, I think, has a vast, research done already. So you can look into how a autonomous robotic system can be integrated into wafer fabrication. Next, AI enhanced robot manipulation for 3D semiconductor packaging. So packaging of semiconductor also is a sensitive, packaging. So you can see how robotic manipulator can help along with AI to help in packaging. Next is the collaborative robots in smart semiconductor manufacturing, predictive maintenance for semiconductor equipment using AI and robotics, AI-driven robot-assisted lithography for advanced semiconductor nodes. So these are a few 4 to 5 research areas where research can be done still, and you can take it from here. The key takeaways from this session were robotics and AI are transforming the next generation electronic devices. Then integration that offers numerous benefits but comes with the challenges. I have explained the challenges and the limitations and the opportunities equally. Future trends indicate evolving technologies and their applications. Ethical considerations must be addressed to ensure responsible development. So this is any questions I would like to answer. Any questions from the participant?
One of the processes or processes we have cores, different gauges, different types of things for those processes by required special machines for blanking that allows to flatten and also cut it like you do with a blank. For blanking. Give them to the pipeline that enters the die. The pipeline essentially forms the panel. Now, boom. Order on part of those, and then order part of all on the role of body centers take all stamping panels next. We bring all that together in one central location, and that's where we actually put together. We'll start with the underbody, main floor of the car. From there, the body side, that's the internal reinforcement from the outer skin. Self-framing area, take the body side, left body, the front end of the car, we actually marriage it all together. One of the most unique things about the body centers is we actually have 5 different overall elements body shell. Shell piercing exhibits, we have cold metal transfer, additional clothing, under delta spot as well as when the body center is actually a full completed body shell ready to press and every Chinese roll up with these bodies put through there. These conveys with bench charges. There's multiple primer, baseball, click road, all of these types of robots that have visual ability to change to ready to the environment. You have a uniform human body that's coming to John's section where we have a super elegant robot, equal smart card, where every card is attention to the fact by itself. Follows the magnetic stress, and essentially the card is assembled from inside out. When you start the information, we have a variety of problems. People want which one that's all going to move the time body itself. One of the robots that I've always been impressed with you guys is the one that moves that one. And the big robot is able to change to robot handling device, putting the windshield, actually grab the windshield and put some glue around it and put the windshield onto the car and run through the rear glass of the vehicle. We talk about versatility. We have put everything we do back in house. We do majority of our family house itself. We have designed here at facility for very simple and very good for you. Currently, it takes about 2 projects for one of them to go from 1 year old all the way to finish like a piece of art. We constantly try to improve the conversation. We want to push the boundaries of what is done by one art. So it's a constant push. This does not have to be the computer or the website. Everywhere, that's the idea. We don't look to the future. That's how hard I feel about it.
Any questions I would like to take up?
Participants, if you have any kind of questions or any kind of queries that you need a clarification, you can ask the resource person. So the session is now open for the clarification of any of your concerns or doubts.
I think there are no questions, sir. I'll give you the concluding remarks.
Okay.
I thank the coordinator, Dr. A. Chandrababu Garu and Dr. Kiran Kumar Rao Garu, who has coordinated with me for this talk. I congratulate PVKK Institute of Technology for getting this grant of Apple online training FDP on AI integrated next generation semiconductor devices and successfully completing it. I congratulate all the participants who have taken out time from their busy schedule for this FDP throughout all the 1 week evenings and attended for upskilling. Congratulations to all of you. Thank you.
Thank you, Pooja ma'am, for that enlightening talk and also for the convergence for the additive manufacturing, machine learning and materials, and manufacturing and robotics. Your presentation has not only showcased the exciting advancements, and the video has really projected the significance of what you have spoken just now. Thank you once again, ma'am, for your time and for your presence in this FDP.
Thank you so much, sir.